Hi. Thank you guys for coming back for lunch for me. It's my pleasure. My name is Scott Traver, and we're a CockroachDB customer. And I'm coming from a company named Spreedly, where I'm a senior principal architect. And I want to tell you a story that is going to sound very familiar, but I hope also gives you some strategies and tactics and insights into what the journey to CockroachDB has been like for us. So first, a little bit more about myself and Spreedly. Like I said, I'm a senior principal architect there on the application engineering team. Spreedly is a payments orchestration company. Our vision is that the world is better with a diversified and inclusive payment ecosystem. And our mission is to accelerate commerce with an open, secure, and flexible payment platform that welcomes all payments participants. I know that payments orchestration can be a mouthful. So in a little bit simpler terms, we kind of sit in the middle of the financial industry. So we provide vaulting and tokenization services in which small businesses and merchants can vault payment methods with us. So we take on the PCI and compliance burden. And it's a little bit of an integrate once, use anywhere strategy, where once they do that, they can use that token with us at any of our integrated payment gateways or any of our third-party fraud providers. And we can provide value-added services onto the payment methods that you store with us as well. So that's a little bit about Spreedly. And when I joined, I really had to think about what our data needs were. So as an API company and a web company, we had basic application data. And we didn't know what products we were going to make, so we had to be very liberal in what we accepted to that first data store. We knew that in finance, we would have a vaulted data store as well, which has some very interesting constraints on it around not being able to scan the sensitive data once it's vaulted. Also, payment methods are very long-lived relative to other forms of data, and so we needed some long-term storage for this data as well. And finally, again with the financial industry, every penny is accounted for. So we knew that we would need record of everything that was happening in our systems. The deeper I got into this, the more I realized that what I thought our data needs were and what our actual data needs were different. So the application data began to kind of take shape as the primary features became defined. And the data became a little bit more customer-centric. The customers wanted a little more ownership over it. They wanted data localization and things like that. The vaulted data that we thought was individual payment methods became batches of payment methods and sets of payment methods that we either imported or exported or that customers moved between their environments. Even product started to ask us to do value-added services on sets of types of payment methods. And finally, the transaction data also took shape, but we needed to segment out the financial transaction data from the application history data, because for financial reconciliation, they're only interested in the financial part of that. So we had to remodel our transaction events. So hands up here, who collects something? Who has ever collected anything? Don't be shy. This is not a judgment on your Pokemon card collection or anything. It's human, right? Humans are collectors. Well, our systems are collections as well. We just happen to have a word for it. And it's tech debt. What's interesting is our systems are collections in the way that if you go on vacation and you get a stuffed teddy bear, and your friend sees it at your house, and he goes on vacation and gets you a stuffed teddy bear, and your other friend sees it and thinks it's funny and mails you a stuffed teddy, pretty soon you're a stuffed teddy bear collector, whether you like it or not. And that's what happens with our systems. But they suffer an interesting characteristic that I've recently found a term for. It's called the Lindy effect. Has anybody heard of the Lindy effect? One hand, great. The Lindy effect is an interesting property, and it says, for living things, the longer they're alive, the closer they are to end of life. For non-living things, the longer they're alive, the farther they are from end of life. For non-living things, the longer they're alive, the farther they are from end of life. What this means is for our systems is that the longer you have a system, a little bit of a if it ain't broke, why fix it mentality, where the more something proves itself, not only is it harder to replace, but less likely that you'll replace it. And what this means is modernization is a responsibility, not a necessity. So one of the reasons that Spreedly went on this modernization journey is because our systems were doing just fine. They were scaling linearly with our business, which is not the scaling that you want. So we took on the responsibility to our customers so that we could scale and provide first best-in-class services. And we took it on as a responsibility to our engineers so that we'd use the latest and greatest tools and become a more efficient engineering organization. Here's an example of our system. This is where it started. Let's think back to what we thought our data needs were. We needed application storage that was very liberal in what it accepted. So we implemented a key value store. We knew that we need some object history, so we bolted on object history. We knew that we had sensitive data, so we bolted on some sensitive data filtering. And then we got our kind of downstream event stream that we could put in our data warehouse and have our secondary business applications be serviced through. And finally, what was the last thing we needed was bulk and batch operations. And so we used that data stream to go to an indexing application and put that indexing into a database. And then the application can now get sets of keys from the indexing application, and then it can iterate through them and get individual things from the primary database. And I see a lot of nodding heads, and it's not just my coworkers down front. This is a classic teddy bear collection in which imagine a system where get by key works, but get latest might not. This is what happens when we have this split brain where I like to call this the data cycle, but if there's any gap or lag or operational complexity in this, we have that scenario where get by ID works and get latest doesn't. And worst yet, this was our teddy bear collection. This was all us. And so this was all areas of expertise that we had to maintain internally. And we had a very powerful system. This powers all of our growth and all of our customers' transactions, but we really just needed a superhero to come in and kind of clean things up. Everybody put your hands up if you're a big fan of superheroes. Come on, who's a fan of superheroes? Keep your hands up if you know who this is, or raise your hand. You guys should know this is one of the original web developers, right? And keep your hands up if you know what code I'm going to use, okay? I want everybody, I know it's just after lunch, everybody say it with me. With great power comes great on-call rotations, operational costs, failovers, late night, and burnout. Did I misquote him? I think I misquoted him. It doesn't have to be that way. So this is a little bit about the migration that we'll get into. So lesson 1 is to de-risk the migration by taking it slow. Remember that this is a responsibility that we've gone on this journey, not a necessity. So as a result, for our application data, we came up with a strategy that I like to call the source of truth migration strategy. Alongside the modeling of our data, remember that we're going from schemaless to schema'd, so we needed to model our data, and we wanted to make sure it was right. So alongside it, we put a table that had keys and type, and what that did is something really important. It let us segment the migration of the data from the activation of the data. And that's key because it gave us great granularity in how we did the migration and how quickly we did the migration and how quick our rollbacks were and how much safety we had around those. It also let us discover things about our data, which is really important, such as we learned that our application was generating UUIDs, which were canonically unique, but didn't fit in CockroachDB's UUID column. We wanted to use edge caching IDs, but then after working with the Cockroach Labs folks, we found out that edge caching IDs have a temporal element to them because edge networks know that nothing will come in the past, and that would have created hotspots in our range. And finally, we realized that by letting CockroachDB manage the IDs, we wouldn't take a performance hit on write because we wouldn't need node confirmation in the cluster. Each node can do its own confirmation for the CockroachDB algorithm for UUIDs. So this is what that looked like at Spreedly. This is what that looked like at Spreedly. We've got our data tables and our source of truth. And I really want to highlight here the thick red lines denote the migration, and the dotted red lines are the activation. And we've separated those. So we could migrate type by type, customer by customer. We could even migrate data element by data element and roll back simply by deleting the key in the source of truths table. And as a result, we could repair the data in place without rerunning the migration. And so we'd separated those two components. Our next lesson is don't migrate data that you don't need to. We had a lot of data, and we had different types. And so our application data was good to go through the source of truth migration strategy. But for our larger bodies of data, we did some discovery, and we found out that we had some inefficient data management practices. As is very classic, there's a lot of store at all costs. We knew we needed long-term storage. But as a result, we built an application that favored scrambling and redaction and obfuscation soft delete over hard delete. So we ended up with a lot of unusable data, especially in our payments method space. So as a result, we took a different migration strategy that I'll call the read-through migration strategy. What this did is we put our old data store in a read-only mode. The models were simpler, so we just modeled them. And their existence in CockroachDB was the source of truth. And we got a scenario where we got a little bit of like a migrate on demand piece. And so that this doesn't happen again, and so we don't have unbounded growth, we're using CockroachDB's row-level time to live to ensure that that data flows downstream through change feeds, but doesn't continue to grow our application database. This is what that looked like, and I want to highlight a couple very key advantages that this strategy had. So as you can see, we've got our reads and writes going to CockroachDB, and our old data store is in read-only. What this did is this let us decommission our custom downstream data pipeline before we decommissioned the old data store. It also let us shrink the cluster size and the compute for the old data store because we knew that no writes were going to it. And so that gave us some extra security as we could kind of de-risk it from the business. And finally, it gave us an opportunity. A lot of people are probably thinking, well, don't you get a performance hit if you do migrate on demand? Because we already had some of those bulk and batch operations in place, Spreedly will assume that first touch latency hit. So Spreedly will do cleanup in addition to iterating through things with our existing bulk and batch operations, and we will take the performance hit on first visibility, and our customers will still get that best experience. So our last lesson actually doesn't come from modern superheroes, it comes from ancient superheroes. And this quote is actually from the 7 Habits of Highly Effective People, but I think he was channeling his inner stoic when he said the main thing is to keep the main thing the main thing. I was at RoachFest last year, and I had a notebook, and I was watching the change feed expressions presentation, and I highlighted and underlined and circled something that became a sticky note that's sitting on my laptop. And what that quote was is, change feeds are the admission that CockroachDB does not need to solve all your problems. Change feeds admit that CockroachDB does not need to solve all of your problems. We need to remember that data is an ecosystem. Data, it's not the database, it's not a technology, and it isn't even the data. It's this ecosystem. And with change feeds, we're going to spend 2 days talking about what we love about CockroachDB, and one of the things that Spreedly likes the most about CockroachDB is what it isn't. Change feeds admit that CockroachDB may not be the best machine learning database, or data warehouse, or analytics database, but they give you the tools for CockroachDB to be a team player within your business's larger data ecosystem. And that was really key to finishing this migration in a successful way. So I promise this is the last time I'll show you this scary picture, but this is the existing data cycle that we had. And how did we do? This is what our system is going to look like afterwards. Much cleaner. If we would have taken this migration project in a traditional manner, and perhaps it was a blessing in disguise that we had to merge different data stores and not use something that was Postgres compatible, because we didn't do a traditional lift and shift, which so many organizations do. If we did, we would have only hit line number 1. But instead, we took it slow because we knew it was a responsibility, not a necessity. We didn't migrate data we didn't need to, and we reminded ourselves every day that data is an ecosystem and needed to integrate with the greater business. And as a result, not only did we replace the outdated data store, but we'll remove the data cycle and split brain that came with it. We're going to remove 3 custom code bases, 2 auxiliary databases, and 3 protocols that we no longer have to maintain expertise in. And we reduced a lot of unusable data bloat. And what did we get? We got a cloud-first data storage approach. We now have a common adapter that we can build more applications on top of CockroachDB. It's going to be the foundation for our multi-region and data localization strategy. We're applying the data retention policy as close to the data as possible. And of course, we get our batch and bulk workloads. All of this is really to say, modernization is not a spectator sport. We're all in this room because of the nitty-gritty challenges that come with this kind of a project, as well as to use the latest and greatest technology and meet all of our customers' demands. But like Brene Brown says, you got to dance with the one who brought you, and you got to rumble with your data. So if you have any further questions, me and some of my colleagues are here, and thank you so much for your time.